Hello guys, and welcome to episode number 8, where we're going to be solving 5 problems, this time from the company ESPN. So let's get started here with problem number 1. First of all, we have a table here, just one, no joins. Let's see what we have to do. Let's dissect the problem statement. We have to find players. The condition is who participated in the Olympics. More than one team. Participated Olympics, more than one team. That seems to be the filtering here. And then we have to output the player name. We have to output all of these. So find all the players with this condition. Now let's see what the table here is. It says events. So one row seems to be an event. Let's check it out really quick. One row. So this is the event ID, and then we have a bunch of names. Probably for each event, multiple people can join or are a part of. Okay, so we have to figure out player representing more than one team. So we know that this is not the filter Olympics because the entire table is called Olympics. Therefore, all of them are already Olympics. What we really have to filter for is representing more than one team. So we have to investigate this column right here, the team column. Now we're going to check out the expected outputs to see to get a clue right here. And we can see that in their team here, the pattern that we can easily notice, basically the teams are delimited by this backslash over here. And that means the player is being part of multiple teams. So knowing this, we can easily just filter for the team where we find this character. So we're going to do exactly that. We're going to select what do we have to select. We're going to look right down here at the player name and all of this. We're going to write all of that. So we're going to say select player name. I think it's just name, team, games, sport, medal from. I'm going to copy this. I'm going to say where. Now we're going to put our filter, which is we're going to find this character anywhere we find it in the team column. And that should give us an error because I wrote wrong here from. Now I fixed it. So there you go. This would be the final answer. And let's check if this solution is correct. Seems fine. So again, just to quickly recap, we selected simply a bunch of columns, and we just have one single filter where we are looking for this character right here, the backslash. If we find the backslash, that means the player has been in more than one team. Now, problem number 2. Let's see what we have to do in this one. Let's dissect the problem definition. Find quarterbacks, most interceptions. This seems to be an aggregation here. In 2016, and this is a filter, 2016. We have to output quarterbacks, corresponding number of interceptions, and then we also have to sort by interceptions in descending. So we have to show quarterbacks and the number, the aggregation basically. With this 2016 filter, we have to sort by the end of it. All right, let's do that. To find, select, let's choose our basic select from QB stats. We're going to select here QB and the number of interceptions. Now let's figure what interception could possibly mean. We have here year, home, okay. It seems it could be this one, INT. I'm not a baseball guy, so I'm assuming this is going to be it. But you see here, when we do a sum of int, because it's an int, it's going to be red. This is a terrible, absolutely terrible name. If you look right here, this is an absolutely awful name because it's a data type. You never want to name your columns like this. So in this case, we're going to get an error, but we're going to continue here. We're going to say where. We're going to apply our 2016 filter right here. We're going to say where. That must be something like year. Yes, we have here year. We put our filter. Now we have to order by interceptions. So we're going to order by this one right here. Since we have one column here and another column here, this is 1, this is 2, we can just simply write 2 and then descending. And ignore the error for a second. We have to sort, okay. So this is the final result. Now, why do we get an error here? We get an error at line 1. Well, it's because of this here. The sum of int, that doesn't stand well with the compiler, okay? So to fix this, we have to actually mention the table manually from where we're selecting this column. And in this case, that's going to fix it. But we're going to rename it the interceptions to make it look nicer. And that would be, actually, we have to group by. We forgot to group by. We don't need to find one. We actually need to find quarterbacks most. So we need to find all of them. We have to group by. We're going to put group by QB here. And there we go. This would be the final answer right here. We're going to check for solution. Everything seems to be green. We're all good. So let's quickly recap what we did here. We found all of the entries, all of the players, and we just sum this one stat that they had. In this case, it's this one, the interceptions, which is terribly written. So we have to manually mention here this the table name again. Otherwise, we're going to get an error. Then we are simply having a filter on the year here. We're grouping by QB because we are using an aggregation here, the sum aggregation. And then by the end of it, we are simply ordering by the aggregation descending from the largest to the smallest. So that's it for problem number 2. Let's move on. Problem number 3, let's go. Let's see what we have, the probably same table, yeah. Now, what do we have to find here? Problem number 3. Find top 10. Oh, perfect. As soon as you read top 10, you shouldn't be thinking, oh, perfect, I'm just going to use the limit 10. No, you should be thinking rank, dense rank, row number. This is what you should be thinking. This is going to benefit you in the long term more than just limiting by 10. Yes, in some cases, when you're at your analyst job and you have to do a quick one, yes, you can just say limit 10. That's fine if you know the data. But if you don't know the data well, then I would highly recommend using a window function. So that's what we're going to be using here. But let's dissect the problem. We have to find top 10 quarterbacks. And then they are sorted how? By highest game points. So they're sorted by, this is a filter, and the aggregation highest game points. We have to output the quarterback with game points. Then we have to order based on game points descending. Game points descending here. Top 10 rows. Now if we have to read this carefully. It says just output the top 10 rows without considering any ties in game points that would result in more than 10. So they just want, what they want literally is they want 10 rows to be output. They don't care if all of them are the same. For example, if there will be 10 people with the same score, it doesn't matter. We just have to output 10 rows. So that means we cannot use something like dense rank, because then we could get equal values. We cannot even use rank as well. So the only option left is to use the row number or the limit. But I highly encourage you to use row number and not limits. Let's write here our CTE to make it cleaner, easier to read. We're going to select, what do we have to select? QB and game points. And then we're going to rank them here. Row number over. We're going to do it by order by, it even says here, descending order, game points. So that's how we're going to order them. Game points descending. We're going to name this column RNK. We also have to put our from statement here. This is the table name. And we have to filter for year equals 2016. As you can see here, year 2016, year 2016. We have to filter for that. Now, from that table, which has 3 columns, we're only going to select QB and game points. We're going to choose our CTE table, and the filter is going to be where RNK less or equals with 10, because we only want to show up to 10, including 10. So this would be the final answer right here. If we check out the expected output, check the solution, everything is fine. So this is, I would highly recommend a solution like this and not just using the limit. Okay guys, problem number 4 right here. Let's see what we have to do. A single table again, same table that we just got familiar with. Let's go. Let's see what we have to do here. Find top 10, okay, top 10 ratings, top 10 ratings. Quarterbacks, output the quarterbacks along with rating. This is identical with the previous one. Because if we look back here, this one highest game points. And in here, we just have to say top 10 ratings. So we're just going to literally copy all of this. We're going to paste it here. And we're going to remove this filter because we do not have a filter here. And then we're going to simply replace this column, the game points. We're going to replace it with something called rate right here. I'm going to take rate, and rate here. I'm going to run the code. Let's see if it's correct. Everything is correct. That was very fast. Now let's reread this again. Let's recap it. Find top 10 ratings. Quarterbacks received. Output the quarterbacks along with corresponding rating. Now top 10. In this case, it does not mention the difference between row numbers and rank. So here, I'm curious if we use the rank function. Well, the solution is going to be the same because there are no tied values here. But I would say in this case, we should use the rank or the dense rank. It's a bit unclear what we have to do. Top 10 here, some people want it in different ways. Some people just want 10 entries, but here is top 10. So we're just going to use the rank one for this case. We could again use limit, but again, try to stay away from that. Okay guys, problem number 5 and the final one for today. Let's see what we have to do here. So find games. This could be a filter, Olympics. Youngest, oldest, this sounds like an aggregation. Athletes could be a filter. Participated, that could also be a filter, but unlikely. And now we have to output all of the details. So we have to literally output the asterisk. Let's see if Olympics is probably actually not a filter. Why? Because the table is called Olympics. So this one is not a filter. Athletes, well, again, we have here athletes. So this is probably, again, not a filter. Not a filter. And then events. So one row is one event. And what we have to find is we have to find the games where youngest, oldest athletes. Youngest, oldest. Clearly, we have to do something with this column, the column age. We have to find the games. This is what we have to actually show. So what we have to show is these, mainly these. But we're going to show all the columns because it says output here. It says output, all the details containing to that record. So I don't know why actually they even say they want to find games when they say to output all of the rows. It doesn't really make sense. It should just be this row and that's it. But whatever. We're just going to output all of the rows. Now we have to basically find the rows where the minimum and maximum are met. We just care about two values. So we're going to have just two rows. So how we're going to be doing that is select from. Now we're going to put everything here. And now our filter is going to be based on the age. So the age, now think about it, the age has to be either the smallest number or the largest number. So minimum and maximum. Now, how can we find minimum and maximum? Very easy. Well, we can just write a subquery. So select minimum age from the table. And this number here, this is going to be a number, right? This is going to be equal to some number. It's going to be the minimum. All of this is going to be one single number. So that was the minimum. Now we can copy paste this. This is going to be the maximum. So again, this is going to be another number. So here we have one number and here we have another number. This is the minimum and this is the maximum. We have two numbers. Now age can be either of these two numbers. So the conditions here are simply, it can be this or this. Now, how can we easily make an OR statement? Well, we can write it the longer way. We could say this equals with the minimum, or we copy everything here, or we could say age equals with the maximum. We're just going to delete this down here. And we're going to get an error because I forgot parentheses. Okay. I forgot this parentheses down here. And now this would be the output. You see the minimum 16, the maximum 73 in this data set. But look at this. This looks absolutely awful. And it's very redundant. We write this twice. It's not good. It works, but we can do it in a better way. We can just use, instead of using OR, we can use the in, which is going to look in a list. It looks cleaner. So we're going to say in, and here we can put a list of values. So the values that we care for, we're just going to copy, are this, or it could be the maximum, or this. I'm just going to put it like this so we can actually see clear. Now I'm going to comment these out. So instead of using it like this, this just visually looks cleaner, easier to understand. We're going to run this. We're going to get the same output here, 16 and 73. So just to quickly recap, we want to show, well, I don't agree with this example because it says find the games, but then you output everything. It doesn't really make sense. What should have been, it should have been just games. And there you go. This should have been the answer. Find Olympic Games. And there you go. These are the Olympic Games. But then you output all the details. That doesn't make much sense. It's a bit confusing. But anyway, if we look at the expected output, we have to actually output it like this. Check solution, everything is fine. Okay guys, that was it for this video today. Thank you for watching, and if you enjoy these kinds of problems and want to get started yourself, I highly encourage you to join the StrataScratch community. Consider using the affiliate link in the description. It is of tremendous help for a small creator like me. Thank you for watching, and I'll see you in the next one.